4.1, we're looking at radian and degree measure. We're going to describe angles, use radian and degree measure, and then use angles and the measure to model and solve real-life problems. So angles, we know, have a vertex. They have an initial side and a terminal side. So initial side, terminal side, and the vertex is here. Now, an angle in standard position, the initial side starts on the positive x-axis, and then it rotates here. So initial side is here, and it rotates this way, and this is our terminal side on this side. Okay, so an angle in standard position is that it starts on the positive x-axis. So let's look at a couple more things. So the angle can also rotate a different direction. So what we have is that we can have a positive angle. Positive angle rotates counterclockwise. So positive angle. And then we can have a negative angle, and that rotates clockwise. Now, another thing we could have are what's called coterminal angles. Coterminal angles. They begin and end at the same point. So if we can have an angle that rotates this way, and so we'll call that alpha. And then we can also have an angle that rotates this way. And notice that they start and end at the same spot. We'll call that beta. So we could also have an angle that rotates only here, so that's our alpha. And then we could have another one that rotates around and through. So again, those are coterminal angles because they begin and end at the same spot. So just some definitions. Radian measure. 1 radian is a measure of a central angle theta that intercepts an arc S equal in length to the radius r of the circle. So algebraically, this means that theta equals S over r. So the circumference of the circle we know is what? Circumference is 2 pi r. So 1 full circle corresponds to an arc length of S equals 2 pi r. And S over r has no units. It's a real number. Okay, it's a real number. The measure of 1 revolution is S over r, which is 2 pi r over r, right? So S is here, the 2 pi r, and then the radius. And then so what that is that it is 2 pi radians is 1 full revolution. So knowing that, half a revolution, you go 2 pi over 2, you get pi radians. If you go 1/4 of a revolution, then you go 2 pi over 4, that's pi over 2 radians. And then 1/6 revolution, it's 2 pi over 6, so that's pi over 3 radians. So here are some common angles shown below, and hopefully you remember that last year from Algebra 2. So we're going to label the coordinate plane with the quadrants and angles between 0 and 2 pi. So if we remember, this is quadrant 1 here. Quadrant 2 is on the left. Then we have quadrant 3 down here, and then quadrant 4. We know that, let's just talk about in radians. So theta is between 0 and pi over 2. This is pi over 2. And this is pi. So in this quadrant 2, theta is between pi over 2 and pi. And in quadrant 3, this is 3 pi over 2. Theta is between pi and 3 pi over 2. And then this last one, theta is between 3 pi over 2 and it ends at 2 pi. Okay, so it's 1 full revolution. So we're going to find some coterminal angles. Determine 2 coterminal angles, 1 positive and 1 negative for each angle. So what we're doing is, if we were in radians, and we're just going to add or subtract And it could be multiples of 2 pi in order to get a positive and negative. So we have 13 pi over 6. So if we subtract 2 pi, so we need a common denominator. So 3 pi minus 12 pi over 6. That is pi over 6. That is our positive angle. Then we could just subtract another 2 pi from here. So we can say pi over 6 minus another 2 pi is going to be pi over 6 minus 12 pi again. So that is going to be negative 11 pi over 6. So we have one positive and one negative. Then we have negative 2 pi over 3. So let's add 2 pi. So it's negative 2 pi over 3 plus 6 pi. So that's going to be 4 pi over 3. Then we get the negative. So let's just take negative 2 pi over 3 and subtract 2 pi, which ends up being subtracting 6 pi over 3. All right, that's the same thing here. And then so you get negative 8 pi over 3. So go ahead and try these two examples here. Find a positive and negative coterminal angle. Okay, if you try this out, you would have gotten pi over 4 and negative 7 pi over 4 for A. For B, you would get 5 pi over 3 and negative 7 pi over 3.